Today, let's go over a medium that I just solved on myself after kind of struggling for a while with time limit exceeded, and I finally managed to figure it out on myself, so let's go over it. This one's called minimum index of a valid split, and basically it's a similar question to the one I did previously. That was really easy for me. This one was a little harder, but still manageable. An element x of an integer array of length m is dominant if the frequency double the frequency is bigger than the length of the array. And essentially they're just asking you to find the minimum index of a value that is on both sides, and both of them, the frequency of that number is times 2 is bigger than the length of either array. So for example, here the index would be 2 because 2, this is the first half, this is the second half. In this case, the frequency of, let's see here, sorry, 2 is here, right? So the frequency of 2 times, so this appears once, times 2 is 2. 2 is bigger than length of 1. This 2 appears twice. 2 times 2 is 4. 4 is bigger than length of 3, so the minimum index will be 2. So you want to find this for every single array, and if there's not, then you just return -1. So let's go ahead and think of how to, first let's break this down. Let's try to split the array into 2 halves at every turn, right? So let's create a lefts and a rights sorted list. Let's not worry about anything else, just try to split the array first. So rights.remove nums of I, because rights contains everything at the beginning. Lefts.add nums of I, and now let's print lefts and rights. Just want to make sure. Cool, so now we're getting everything, basically splitting here, and then also splitting here. But we also want to split at the beginning because you notice that I can be equal to 0, bigger or equal to 0. So maybe we should move this up here and see. Okay, so now we have, looks like a valid split. Except now we want to make it so that there's nothing on one side here as well. So how do we do that? Okay. Maybe we print it again. Okay, maybe we print lefts and rights again. Cool, so now we have everything split. So now we want to keep track of the frequency on the left and the right side. So, we want to make this more pretty though. I don't want this to be here. So rights.remove, lefts.add. I feel like that's what it should be though, because okay, but now we don't have anything here. You know what, let's not worry about that because we're just going to reflect the frequency of each sides in a dictionary. So we're going to create a dictionary for both sides. Let's call this leftsd and rightsd equals to counter. So it's empty and then counter of nums. Let's print leftsd and rightsd. So each turn we're basically just saying rightsd nums of I minus equal to 1 if rightsd, or maybe we can add first because maybe that'll change the way it looks. Let's do this. Okay, I guess not, but okay. So at least the dictionary looks the same, but now we have to say leftsd nums of I plus equal to 1, rightsd nums of I minus equal to 1, right? We're seeing one less because we're removing one instance of it. So honestly, the sorted list doesn't even matter. So if rights d nums of I is equal to 0, then delete rights d nums of I. Okay, so, okay, cool. So honestly, we can just get rid of this sorted list. It doesn't even matter. Because splitting is done, we only care about the frequency. So, don't care about that. Left's d, right's d equals to counter of nums. Cool. So now that's exactly what I'm talking about. But actually, it doesn't even matter because the left, this has to have one element. There has to be an element on both sides. Have the same dominant element. So actually, I was right before. That's fine. We can do it like that, or we can do it like this. We just basically don't care about this one. So now we have to basically ask the question, right? So at any point, is any key's value in both keys times 2, are they both greater than either side? So here, 2 times 2 is 4. 1 times 2 is 1. That is, let's see. Actually, maybe we have to print this. Let's just print lefts and rights as well, just so we can have a clear idea of what the array looks like. Rights dot remove nums of I. Okay, so the array looks like this, the sides look like this. So at this point there's a valid split because let's see. So for example, here is actually 2, so 2 times 2 is 4, is bigger than the length of this. So 0, 1, 2 is actually here. And then 1 times 1 is 1 times 2 is 2 is bigger than the length of this. So the list comes below it. That's what we have to look at. So cool. So now, right, this is originally what I had. So let's go over left's d and say if L is in right's d as well. Cool. We have to find the union of the keys. And then if left's dl times 2, the frequency is bigger than, let's call this left's lane is length of lefts, length of rights, and then each time you can say left len plus equal to 1, rights len minus equal to 1. So bigger than left's len, this is just to avoid time limit exceeded, and rights d left, same key we're talking about in both dictionaries, is bigger than rights len. Then we can just return I minus 1 because that's the index that was validly split. So left's len okay, plus equal to 1, yep. Oh, sorry. Okay, and at the end, if this is not possible, then we can just return -1 if there's no valid split we ever detected. So cool, so basically almost solved, but it'd be great if this worked, which it doesn't. So I'm going to show you another trick that I used, that I found. Okay. Okay, so you're almost there, right? So now, instead, let's, because this is really costly, we only want the same keys between the two dictionaries. So, and we want the same keys that are, if the value times 2 is bigger than the length of that corresponding list, then only we're interested in it. So we can create a set called scene. And at the end, after we do all the things with the dictionary decreasing and increasing by 1 on the left and the right sides, we can just say if left's d, nums of I, the current element we're dealing with, times 2 is bigger than left's lane, then we can add that element because that's the key we're interested in. right? The frequency is on the right, the actual element is on the left. If right's d, nums of I, same thing, times 2 is bigger than right's len, then add it, and instead of iterating over all the keys, we can just say for s in scene, if s is in right's d, right, call this s. Hopefully that helps. So we're not iterating over everything we don't need, and as you can see, that's what it takes to get over the time limit hump. So I'm really happy about that I managed to figure this out by myself. Also, another thing you can do is say, doing this, I don't know if this makes a difference in time complexity, but it's just you're not recalculating it. Okay, I guess it doesn't, but yeah, hopefully this makes sense. We're only caring about the frequencies that are the same between the two dictionaries. So we don't even need this sorted list. We just need the dictionary because we care about the frequency. So hopefully this made sense. I know it was a bit confusing, and if you found this helpful, please stay tuned for more and consider subscribing.